So the problem says if g of x is equal to x squared plus 6x, with x being greater than or equal to 3, we want to find the inverse of g at 55. But what this is really asking us is, um, we're looking for an x value of our function g such that g of x equals 55. Because remember, when we're doing inverses, the inputs and the outputs, or the x and the y coordinates, are interchanged. So when you're comparing a function to its inverse, the inputs of the function become the outputs of the inverse, and the outputs of the function become the inputs of the inverse. So we just basically asking ourselves this question: when does g of x equal 55? And we can solve that algebraically. So we have an expression for g of x, which is x squared plus 6x, and we know that equals 55 because we're asking specifically when is this function's output 55. So we're going to go x squared plus 6x equals 55. And we're going to solve this. So we subtract 55 from both sides. It gives us x squared plus 6x minus 55 equals 0. Then we're going to factor this quadratic on the left side of this equal sign into the product of two binomials. That gives us x and x. So we're looking for two factors of negative 55 that sum up to a positive 6. That would be a positive 11 and a negative 5. Then we're going to use the zero product property to set each of these factors equal to 0 and solve. So we have x plus 11 equals 0. We solve that and we get x equals negative 11. And then we have x minus 5 equals 0. We solve and we get x is equal to 5. But we have to recall this restriction on the domain. We were looking for values of x that are greater than or equal to 3. So what that does is that kind of throws out this negative 11 value, because we only want values that are greater than 3. Since we know that g of 5 is equal to 55, because we're looking for the value of the inverse function at 55, we just switch the inputs and the outputs. So that also tells us that the inverse evaluated at 55 equals 5.